Alright, today we're going to find common units or number of units to compare to fractions. So we're still going to use tape diagrams. If you're comfortable with it, you can still use a number line. However, we are going to start using kind of an algorithm way of thinking to compare to fractions. So let's start out with, Zern wants me to use apples, but I like peaches more. So I'm going to use peaches. What's greater here? One peach? Three peaches. Three peaches. So I could say that three peaches is greater than, well, if it'll let me write, is greater than one peach. If I were to look at now fractions in a tape diagram, I have 1, 2, 3, 4, so I have fourths. I have 3/4 and 1/4. So I ask myself, same way with the peach logic, 3 peaches is greater than 1 peach, so 3/4 is greater than 1/4. Now, if you were to find a similarity between these two slides, the peaches and the fourths, you would see that I'm comparing fractions to fruit, but my units are the same in each one. So here, I have a different amount, but they're all peaches. I have a different amount, but they're all fourths. Now, if I were to change my units and maybe want to compare 1/4 to 1/5, now I have some similarities in the numerator department, but my units are quite a bit different, fourths and fifths. So how would you go about determining whether 1/4 or 1/5 is greater? You could use what we've learned a few weeks back, or days back, a few lessons back anyway, and you could realize that the more you partition a rectangle, the smaller the pieces get. So the higher the denominator, the smaller the pieces. So here I basically have one large piece and one small piece. So 1/4 is greater than 1/5. Now if we look and compare 2/4 and 2/6, we can really get a visual on what we're talking about piece size. I have 2/4 and 2/6. If you look at the piece size of the fourth alone, it shows that 2/4 is greater than 2/6. Now, even if my units on the top, if my numerators are the same, the pieces, the denominator, is smaller in fourths, so my pieces are going to be larger. So if I have two big pieces, that beats having two small pieces. Just like I know that if I have 2 inches, that is less than 2 feet. 2, but the size difference are drastically different, inches to feet. That's comparing just your fingertip to your entire foot. It's quite a bit different. So just the way I know that 2 inches is less than 2 feet, I know that 2/6 less than 2/4. Now we have a special word for these kind of situations, and that is summed up in this picture right here. And I picked this picture kind of at random, although I both think these actors are pretty funny. But if you look at these actors, are there similarities between them? I mean, besides their suit and their ties, the shirt color, both have darker eyebrows. They both have a start of a beard going. They both have high hair with a little bit of wave to it. Their eye color is kind of the same. The shape of their head is the same. They have things in common, which means that they have similarities, but they're not the same person. So let's check out this next one. This top fraction is 1, 2, 3, 4, 5. 5. How many total? 1, 2, 3, 4, 5, 6, 7. We have 5 sevenths. And down here we have 1, 2, 3, 4, 5. 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5 twelfths. So if we look here, what do we have in common? Our numerators are in common. So they both have a 5 in the numerator. That's excellent. Now we look at the size of the pieces alone. Sevenths, just this piece right here, compared to this piece right here. The sevenths is that much bigger. So if we have the same amount in the numerator, the sheer size difference of the pieces make all the difference. So here we have 5 sevenths is greater than 5 twelfths. Now if we go to this next one, here we have 1, 2, 2, come on, 2 out of 1, 2, 3, 4, 5, 6, 7, 8. And down here we have 1, 2, 3, 4, 4 out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, our job is to look for things that they have in common. Things that they have in common. I don't see any. Numerators are even. Denominators are even. Let's see, we have... That's about it. So they don't right away have anything important in common. However, based on what I know about facts, I can see that 2 is a factor of 4, which means I can multiply this 2 by something and get 4. 2 times what equals 4? 2 times 2. I'll write that a little bit better. Come on. What, did I just walk into school, sit down, and start yelling about things? No. There. That's fancy. So I can multiply 2 by something and get 4. 2 times 2 equals 4. Now, I did something to the numerator, which means that I have to do the exact same thing to the denominator. So what I've done here is I've taken these 8ths and I've cut them, partitioned them in half. Because I started with 8, and now at the end, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now, when I look at 4 sixteenths, our equivalent fraction, 4/16 and 4/10, I see that there are 4. 1, 2, 3, 4 is in common. So we have common numerators now. We can go back to what we know about sheer size of the pieces. And we know that if we have 4/16 and we're comparing it to 4/10, their numerators are common. However, 16ths, that's tiny, tiny pieces. Therefore, 4/16 is less than 4/10. But in our original equation here, it was 2/8. So we write it 2/8 is less than 4/10, shown on this tape diagram. Now, it isn't always the numerators that have to be in common. Now, many times you can't get a common numerator without trying really, really, really hard. Sometimes you have to look at the denominator. So let's do this next one here. We have 1, 2, 3, 3. We have 1, 2, 3, 4, 5 with 3/5. And we have here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I look at my fractions and I see that 3/5 and 7/10 don't have anything in common right away. That's a problem. And I know, just based on my fact knowledge, that if I were to try to get 3 times something and equal 7, well, that'd be impossible. So now we look at it again. Some other things. I know I wouldn't have to equal 7, but based on what I know about my basic facts, well, I know that I can take 7 times something, and 7 and 3 have a multiple in common. 3 times 7 is 21, and 7 times 3 is 21. Oops. Now I did that to the numerator, so I have to do it to the denominator. Oh, anybody catch that? And what I did down here to the numerator, I have to do to the denominator. Now, I don't know about you, but I don't want to sit here and partition out this tape diagram into 35 pieces. Ugh, that doesn't even sound fun. And I don't want to sit here and partition this tape diagram into 30 pieces. So knowing that I just don't want to do that, I'm going to go back to the drawing board. So there's got to be another way. There's got to be. I should be able to multiply and get a common something that helps me avoid partitioning this tape diagram into 35 pieces. So still, using our knowledge of basic facts, look at these. What do you notice? Anywhere. It doesn't have to be the numerator. I notice that 5 is a factor of 10, which means that I can multiply 5 by something and get 10. 5 times what equals 10. 5 times 2. If I did that to the denominator, I have to do it to the numerator. 3 times 2 is 6. I like that a lot better. A, because I can sit here and I can partition each fifth in half in a matter of seconds. And double bonus, I don't have to do anything to this bottom line. So let's check it out. 3/5 now is equivalent to 6/10. What do they have in common? They have common denominators, not numerators this time. They have common denominators. So quickly, I need to partition each fifth in half. And I can see that I have 1, 2, 3, 4, 5, 6. Bingo! I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6/10. And now I can clearly see that, not by like a whole lot, but 7/10 is obviously 7/10 is obviously greater than 6/10. Because that takes you back up to peaches. Your unit here in the tenths, they're peaches. That's our unit. They're peaches. Now, which side has more peaches? Here, if we look at 6 peaches compared to 7 peaches, 7 peaches is greater. And here we have 7/10 is greater than 6/10. However, when we write our final answer, we can't use equivalent fractions. We must use 7/10 is greater than 3/5. This is how you must write your final answer, using the original fractions that you were dealt with at the beginning. In the middle, you can use however method you want to find out which is greater, which is less than. Now, we could have used that 35 and 30. That's fine, but partitioning it into tenths was a heck of a lot more appealing to me. Now, just to review, 3 peaches is greater than 1 peach. They have the same unit, peaches. They're the same fruit. However, you just have more of one. If we are comparing 2 inches to 2 feet, yes, they have something in common, which is that 2, but 2 feet is obviously bigger than 2 inches. So we come down here, we ran into some times where the fractions didn't have anything in common. So we had to make them have something in common. Here we knew that 2 was a factor of 4, which means that 2 times 2 we could get 4. We could score common numerators. Here, scoring common numerators would have been a pain. So we decided to check and see if we could get some common denominators. And, as luck would have it, 5 is a factor of 10. So we had to multiply 5 by 2 and get 10. And what we did to the denominator, we had to do to the numerator. And we found an equivalent fraction, which was 6/10. We were able to easily partition our tape diagram into tenths. And we could see then that 6/10 was totally less than 7/10. All right, good luck.